Hi dears, I am Sivaselvi, Assistant Professor in Chemistry, St. Joseph College for Women, Tirupur. Today we are going to discuss about the topic superconductor. First, let us see about what is a superconductor. A superconductor is any material that can conduct electricity with no resistance. Superconducting materials are metals, ceramics, organic material and compounds. Metallic elements or compounds have some resistance at room temperature. Less resistance at a temperature is called critical temperature. For examples of superconductors are aluminium, niobium, etc. Copper, silver, gold. These three are best metallic conductor but are not superconductor. The graph plotted between resistance versus temperature. Superconducting material can transport electrons with no resistance and release no heat, sound and other energy forms. Superconductivity occurs at a specific material, that is critical temperature. As a temperature decreases, a superconducting material resistance gradually decreases until it reaches critical temperature. Next we discuss about types of superconductors. There are two types of superconductor, type 1 superconductor and type 2 superconductor. First one, type 1 superconductor. These types of superconductor lose their superconductivity very simply when it is placed in the magnetic field at the critical magnetic field. After that it will become like a conductor. These type of superconductor, also named as soft superconductor, are also named as soft superconductor due to the reason of loss of the superconductivity. Type 1 superconductor obey the Meissner effect, that is expulsion of magnetic field. Type 1 superconductor obey the Meissner effect completely. These type of superconductor are very low temperature. For example of type 1 superconductor are zinc, mercury, aluminium, lead. Next one is type 2 superconductor. This type of superconductor will lose their superconductivity slowly but not simply, as it is arranged within the exterior magnetic field. We observe the graphical representation between the magnetization versus magnetic field. When type 2 superconductor, it will be loss of the superconductivity slowly. This type of superconductor is also named as hard superconductor due to the reason of loss their superconductivity is slowly. This type of superconductor will obey the Meissner effect but not completely. Next, properties of superconductor. First one is zero resistance. When the material is cooled under its transition temperature, then its resistance will be reduced to zero suddenly. For example, mercury shows zero resistance under 4 Kelvin. Next properties are Meissner effect. When the superconductor is cooled under the critical temperature, then it doesn't permit the magnetic field. This is known as Meissner effect. Next one is critical temperature. This temperature is also known as transition temperature. When the critical temperature of superconducting material is changing the conducting state from normal to superconducting. Next one is critical current. When the current supplied through a conductor under the condition of superconducting, then the magnetic field can be developed. If the current flow increases, the flow of current value is known as a critical current. Next properties are persistent current. Persistent current is a electric current not requiring an external power source. Last one properties is thermoelectric effect is absent. Next, uses or application of superconductor. First one, medicinal field. Superconducting Superconductors are mainly used for creating powerful electromagnetic in MRI scanner. So these are used to divide. They can also be used to separate magnetic and non-magnetic material. Next one, electric field. These are used in generator, particle accelerator, transportation, electric motors, power transmission, induction heaters and magnetic energy storage. Next uses are electronics. This conductor used to high speed computing device It is used to transmit power for long distance, used in memory or storage element. Next uses are physics. It is used to particles, magnets and fusion research, etc. Next, advantage of superconductor. Resistant superconductivity material is low, no current wastages, reduce the size and weight of motors and generators, power and cost efficient. Next, disadvantages of superconductor. Low critical temperature, materials are breakable, no ductile and hard to save. It is chemically unstable. It is not applicable for consumer electronics. Thank you.